Hi there, and welcome to this lesson. Now, in this lesson, we're learning about simultaneous equations, okay? And under simultaneous equations, we'll be learning the substitution method. Interesting. So, at this point, I'd remind you to set the video to play in 1080p HD. Very important that you do so. And as the lesson progresses, if you have any issues at all, anything comes off as unclear, please feel free to get in touch, okay? You can do so via the course dashboard. Okay, let's jump right into the lesson. So, simultaneous equations, the substitution method. Now, what exactly are simultaneous equations? Now, simultaneous equations are sets of equations that contain more than one variable of the first order. Okay, so, for example, we have x plus y equals 5 and 3x minus y equals 3. So, like we said, simultaneous equations are sets of equations, so they come in sets. Okay, for example, we have a set of two equations here, and they usually contain more than one variable. If you notice, we have two variables at play at the moment. We have x and y in the first equation and x and y in the second equation as well, and the variables are usually of the first order, so you have them just as x's and y's. When you have a variable of the second order, you have it as x squared or y squared, but that's by the way. So this is a set of simultaneous equations. So we have x plus y equals 5 and 3x minus y equals 3. Now, basically, when you ask to solve simultaneous equations, you're pretty much looking for values for x and y that would satisfy both equations. So I have that x plus y equals 5 and 3x minus y equals 3. I'm pretty much looking for values for x and y, okay, that when I add the x value and the y value, it will give me 5. And basically this for the same values, when I have 3 of x minus y, it will give me 3. So let's consider x plus y equals 5. Now, if I assume that x is 1, I could say that y is 4, and basically I have 1 plus 4, it will give me 5. Okay, so when x is 1, y is 4. Now if I said x was 2, if I assumed x was 2, I'd say x is 2, y is 3. Okay, because 2 plus 3 equals 5. Now if x is 3, y is 2. Okay, and when x is 4, y is 1, I can actually keep this going. Like I said, when x is 5, y is 0. When x is 6, y is minus 1. When x is 7, y is minus 2. This would go on forever. Okay, but then when you bring in the second equation, it pretty much constrains things, make things a bit more defined. Now let's work with the second equation. There we have 3x minus y equals 3. Okay, and when x is 1, y is 0. Okay, when x is 2, y is 3. When x is 3, okay, because 3 times 3 minus 6 would give you 3. Basically you have 9 minus 6. So when x is 3, y is 6. And when x is 4, y is 9. And just like we had for the first equation, this could go on forever. But like I said, when you're looking to solve a set of simultaneous equations, this is why they come in sets. When you're looking to solve a set of simultaneous equations, you're actually looking for a point where we have values for x and y that satisfy both equations. And if you look at this closely, you should be able to identify that this happens at the point where x is 2 and y is 3. So when x is 2, y is 3, it satisfies the first equation as well as the second equation. So our answer in this case, if we solve this set of simultaneous equations, we arrive at the answer x is 2 and y is 3. Now, for a set of simultaneous equations to be solvable, the number of equations must equal the number of variables. From the example that we just did, we had two variables and we had two equations. You could have instances where you have three variables at play, and to solve a set of simultaneous equations involving three variables, you would require a set of three equations. For example, if you're given a set of simultaneous equations like this, we have three variables at play, but we're only given two equations. This is not solvable. You cannot solve for the values here. So anytime you're given a set of simultaneous equations, or anytime you have a set of simultaneous equations, the number of variables must equal the number of equations in the set for the set of simultaneous equations to be solvable. Okay, so there are three known methods for solving simultaneous equations. Okay, and basically we have one, the substitution method, the elimination method, and finally the equal subject method. Okay, and we're actually going to discuss the substitution method in this lesson. So the substitution method. Now, how do we solve simultaneous equations using the substitution method, and what exactly is the substitution method? Now, consider the set of simultaneous equations, the one from our previous example, x plus y equals 5 and 3x minus y equals 3. Now, we would not have to list out all the possible outcomes, all the possible values for x and y like we did before. We can actually just solve this using the substitution method. Now, what is the substitution method about? So we're going to label the two equations. I'm going to call x plus y equals 5 equation 1 and 3x minus y equals 3 equation 2. Okay, and then the first thing I'm going to do when I'm solving using the substitution method is I'm going to select an equation and a variable. So I'm going to choose either of the equations, so it could be equation 1 or equation 2, and either of the variables, it could be x or y. So we have, I'm going to work with equation 1. Okay, I think equation 1 would be a lot easier to work with. So I'm going to work with equation 1 and I'm going to work with x. So select an equation and select a variable. So equation 1 and x. And now the next thing I'm going to do is I'm going to make the selected variable the subject of the equation. Okay, so I have that x plus y equals 5. I'm going to make x the subject of this equation, and basically I have x plus y equals 5 and x equals 5 minus y when I bring y over to the right. Okay, so x equals 5 minus y. Now what am I going to do next? Now the next step says substitute the result into the other equation. So we have x equals 5 minus y, and we're going to substitute this into the other equation, equation 2. Okay, remember we started with equation 1, okay, in our first step, and now we're going to substitute our current result into the other equation, i.e. equation 2. So equation 2 is 3x minus y equals 3. Okay, and from our last step we found that x equals 5 minus y, and what we're simply going to do here is we're going to put 5 minus y for x in our equation there. Okay, so we have 3x minus y equals 3. This becomes 3 5 minus y. Okay, x becomes 5 minus y, so we have 3 5 minus y equals 3. Okay, and then we can expand and say 15 minus 3y minus y equals 3. And if you notice something very important here, we now have a single variable in our equation. Okay, and now we can pretty much just go ahead and solve this like we would any simple linear equation, and basically we would end up, when we collect like terms, we'll end up with minus 4y equals minus 12. Okay, and then finally when we divide both sides by minus 4, we end up with y equals 3. So we have arrived at a value for y. So y equals 3. How do we find x? Now to find x, we substitute the result, okay, y equals 3, into any of the other equations. Okay, so we have that we're going to use x equals 5 minus y, okay, which is just equation 1 rearranged. Okay, so we have x plus y equals 5, x equals 5 minus y. And basically we found that y equals 3, so we're going to use this to find x. That would tell us that x equals 5 minus 3, and it will tell us that x is 2. And that is how you solve a set of simultaneous equations using the substitution method. We arrived at our answers: x equals 2 and y equals 3. So let's go over it again. So we have a set of simultaneous equations: x plus y equals 5, 3x minus y equals 3. We labeled them equation 1 and equation 2. Now the first thing we did is we selected an equation and a variable, okay, and in this case we worked with equation 1, and our variable we worked with x, okay, and then we made x the subject of formula in that equation. Okay, we ended up with x equals 5 minus y, and then we substituted the result x equals 5 minus y in for x in the other equation. So x is 5 minus y, and we had that 3x minus y equals 3, so we just put 5 minus y for x in that equation. So we had 3x became 3 5 minus y, so we have 3 5 minus y equals 3, and from that point on, it's pretty much just simple linear equations. We then arrived at y equals 3, and then we substituted y into any of the other equations to find x. Okay, so x plus y equals 5. If y is 3, what is x? And we ended up with x equals 2. Very simple, very straightforward. Let's move on. So I have a few examples here. And example one says solve the following set of simultaneous equations using the substitution method. So I have x minus y equals 1 and 4x plus y equals 9. How do we go about solving this? Now remember, the first thing we need to do is we need to select an equation and select a variable. So select an equation. I'm going to be working with equation 1, okay, and I'm going to be working with x. Okay, you could work with equation 2 and work with y, or work with equation 2 and work with x. It really doesn't matter at this point, to be honest. But then we're going to be working with equation 1, okay, and we're going to be working with x. Now once I've done that, the next thing I'm going to do is I'm going to make x the subject of formula in that equation. So I have that x minus y equals 1. I then end up with x equals 1 plus y. Now, next thing we do is we're going to put x equals 1 plus y for x in the other equation. So our other equation is 4x plus y equals 9. And we found that x equals 1 plus y. And we're simply going to put x equals 1 plus y for x in the other equation. So 4x becomes 4 times 1 plus y. So we have 4 times 1 plus y equals 9. And then we have 4 plus 4y plus y equals 9. And we just solve the linear equation there. We end up with 5y equals 5. And finally, we have that y equals 1. So we have a value for y. Now let's go for x. Now, to find x, we have that x equals 1 plus y, or x minus y equals 1. Basically, that's just the first equation, equation 1 rearranged. It's actually just easier to work with. So x equals 1 plus y, and we found that y equals 1. So x equals 1 plus 1, and we have that x equals 2 as our final answer. Now, something very important that you should do when you're solving simultaneous equations is putting your answer back into the equations. So we have that x equals 2 and y equals 1. From equation 1, we have that x minus y equals 1. 2 minus 1 equals 1. So that is correct. Okay, and we also have that 4x plus y equals 9. 4 times 2, because x is 2, 4 times 2 is 8, plus y is 1, plus 1 equals 9. So this would tell us that our answers are correct because our values satisfy both equations. So let's do one final example, example 2, and we have solved the set of simultaneous equations using the substitution method. And what we have here is we have 2x minus 5y equals minus 6, and we have minus x plus 3y equals 4. So first thing we're going to do, we're going to select an equation and select a variable. So I'm going to be working with equation 2 in this case, and I'm going to be working with x. Like I said, it could be either of the equations, either of the variables. So we've chosen equation 2, we've chosen x, and now we're going to make x the subject of formula in that equation. And what we end up with is we have x equals 3y minus 4. Now, the next thing we're going to do is we're going to substitute our result for x in the other equation. So the other equation is 2x minus 5y equals minus 6. And we're simply going to put x as 3y minus 4 into that equation. So 2x becomes 2 multiplying 3y minus 4. And then we have minus 5 equals minus 6. Okay, and from this point we expand. We have 6y minus 8 minus 5y equals minus 6, and from this point we're just solving simple linear equations, and finally we end up with y as 2. Okay, so we have our y value. Now we need to find our x value, and to find our x value we simply put y equals 2 into equation 1, into equation 2. Okay, so we have x equals 3y minus 4, or minus x plus 3y equals 4. Pretty much just rearrange that, and we have that y equals 3, and you have x equals 3 multiplying 2 minus 4, and x equals 6 minus 4, and you have that x equals 2. So something important I need to point out here, if you notice all through the lesson, okay, at step 4 I've always made use of the equation derived from step 2. Why? It's just easier. Okay, basically we used x equals 3y minus 4, and we already have that y is 2, so we just put that into the equation, and once you put that directly into x equals 3y minus 4, it gives you a very straight answer. So for step 4, the best equation to put your result from step 3 into is the equation gotten from step 2 when you make your selected variable subject to formula, because at that point it's actually very easy to proceed from there. So yeah, that is how we solve simultaneous equations using the substitution method. It's actually very simple. It's just 4 steps. Okay, first, select an equation and variable. Second, make selected variable subject of the equation. Third, substitute your result into the other equation, and finally substitute your result into the other equation, the initial equation, the one you made use of in step 2. So just 4 steps, very simple. And yeah, bye for now.